Under 7.4, we are told that coding is sometimes used to simplify calculations. And coding is not a new word. We have had this word in several topics. But on page 140, the first three bold sentences are very critical, and we must understand them. The first says, the numbers used in the coding to subtract and divide are selected to make the resulting numbers small. Of course, that is the general idea of coding. The coded regression line may not be the same as the actual regression line. The linear change may affect the answer. You're going to see how. And statement number 3, to carry out a linear change of variables, substitute the linear formula into the answer and simplify. This is going to be seen in example 5, which says 8 samples of carbon steel were produced with different percentages, C, of carbon in them. Each sample was heated in a furnace until it melted, and the temperature M in degrees Celsius at which it melted was recorded. Now, the results were coded such that X, this X is already a coded figure. This X is given by 10C. X is 10C, and Y is given by, and this Y, which is already a coded value, M minus 700 everything over 5. These are the codes that they have been used in this question. The coded results are shown in the table. This is the table that shows the coded results. A, calculate SXY and SXX. We are also told that we may use that sigma x squared to be equals to 204 and sigma xy to be equals to 478. We have been given that information. Straight to the question, SXY. SXY, as we know it, is sigma xy minus sigma x sigma y everything over n. And in this case, we must now substitute, which is sigma xy is 478 sigma xy minus sigma x. In this case, our sigma x is the sum of the whole of the x column. So if we could create a new column there and we call it sigma, then we can have our sigma x to be 1 plus 2 plus 3 all the way to plus 8, which is going to be equals to 36, which is going to be equals to 36. And the sigma y, because at some point we'll need it, is going to be 35 plus 28 all the way plus 6, which is going to be 144. You may confirm that. So we substitute sigma x, which is 36, multiplied by 144, and this part divided by 1, 2, 3, 4, 5, 6, 7, 8, divided by 8, and we have this one to be 170. That is SXY. What about SXX? SXX is given by the sigma x squared minus sigma x squared over n. Just substitute this and have sigma x squared, which is 204, minus sigma x, which is 36 squared over 8. And this one is simply giving us 42. This is going to give us 42. Just confirm that as well. So give it 42. Part B of the question is find the regression line of y on x. Find the regression line of y on x. Finding the regression line of y on x, let's just have this one. We're going to have y is equals to a plus bx. And in this case, we have to calculate our value of b and calculate our value of a at the same time. So our b we know is sxy over sxx, which is equals to, by the way, I hope if you calculate this, which is going to be sigma xy, sigma x, sigma y over 8, this one definitely is going to give you negative 100 is equals to negative 170, as opposed to positive. It is not going to be positive, it's going to be negative 170. Please make that correction, negative 170. So sxx is negative 170 over sx x, which is 42, and our value of b in that case is going to be negative 4.048. That is our value of b. What about our value of a? Our a is going to be, of course, we know the mean of y minus the mean of y minus b times the mean of x. But what is the mean of y? The mean of y is obviously 144 over 8 minus b, which is minus 4.048 multiplied by the mean of x, which is 36 over 8. And this one entirely will give us, because of this negative become plus, will give us 36.216. That is our value of a. Therefore, the equation of regression of y on x is going to be y is equals to a, which is 36.216 plus b, but because b is negative, so plus minus becomes minus 4.048 of x, and this is the equation of regression of y on x. Part C of the question, find the equation of the regression line of m on C. Of m on C. Find the equation of the regression line of m on C. We understood in the beginning that x is already a coded value and y is already a coded value, and the coding system or the coding formulae are here. So every time we see y, we must realize that y is equals to m minus 700 over 5. And every time we see x, we must remember that x is equals to 10c. So the part C of the question is simply telling us to find the regression or find the equation of the regression line of m on C. In other words, make m here or write m in terms of C. Let us see what happens. Y, which is now becoming m minus 700 over 5, is equals to 36.216 minus 4.048 multiplied by x, which is 10c. And at that point, we just need to make m the subject of the formula, And we can already see if you multiply everything by 5, then you're first of all going to find m minus 700 is going to be equals to 181.08 minus 202 minus 202.4 C. Having multiplied everything by 5 and by 5 on that particular side, so that this cancels out, and after opening this bracket, having to multiply everything by 5, you will find that. But we are not yet there. We must make m the subject of the formula, because the question is find the equation of the regression line of m on C. That is meaning that we have to add 700 on both sides, making m the subject of the formula. Then we are going to get is equals to 181.08 plus 700 minus 202.4 C. And of course, when you add this one, it's going to give us m is equals to 881.08 minus 202.4 C. And this is now the equation of the regression line of m. This is the equation of regression of m on C. And that is exactly, if you have noticed, we were able to use the coded value which brought us here. And of course, the part C of the question demanded that we now decode, and this is what we did. We substituted the coded value with the formula of the coding, and we have been able to make m the subject of the formula. And this is now the regression equation of m on C. Okay?